Have you ever found yourself standing in a neighborhood or maybe like a beautifully landscaped commercial plaza and you're just looking up at this massive, majestic shade tree?
Yeah, they really do just command your
Well,
attention.
you admire the sprawling branches, the deep green canopy, the way the sunlight sort of filters through the leaves. It feels, I don't know, permanent, rooted, safe.
Exactly, like it's always been there.
But, and this is wild to think about, if you were to look at that exact same tree through the eyes of a structural engineer, you wouldn't just see a piece of landscaping, you'd see a multi-ton lever
Oh, absolutely.
suspended high in the air, reacting to these immense aerodynamic and hydrostatic forces. And if it's not being managed properly, you are likely looking at a devastating structural liability just waiting for a change in the wind.
It's true. We are so conditioned to view large, mature trees as permanent fixtures of nature, almost like geological formations. But in reality, they are dynamic, growing, constantly shifting biological structures.
Plural.
Right, they're alive and moving. A tree on a commercial property or in a busy homeowner association space, it isn't just a plant. It is a massive structural asset that's suspended over pedestrian walkways, parking lots, roofs.
Yeah.
It requires active, calculated management to prevent catastrophic failure.
And that shift in perspective, that's the exact mission of our deep dive today. We are looking at a highly detailed stack of arboriculture guides and maintenance articles. These were written by John Constantine, who manages these exact issues for a tree service company out in West Covina, California.
A very challenging environment for trees, by the way.
Right, we'll definitely get into that. So we are going to use these guides to uncover the hidden science, the biological warfare, and honestly, the surprising physics behind smart tree care.
It's a lot more technical than people realize.
It really is. We'll explore how neglected trees rapidly transition from being, a property's most valuable landscape asset into a severe hazard. Okay, let's unpack this because reading through the actual mechanics of arboriculture, I realized that taking care of a mature urban forest is much closer to structural engineering than it is to gardening.
Oh, it demands a highly technical approach. When you're managing a living structure that weighs several tons and sits, say, 20 feet from a residential roof, you aren't just giving a plant a haircut.
Right.
You are engaging in proactive asset preservation and liability reduction. Every single cut made by a professional arborist is calculated. It's meant to manipulate the tree's growth patterns, alter its center of gravity, and change how it interacts with the physical environment around it.
Wow. So let's start with the part of the tree everyone actually sees and interacts with, the canopy.
The crown.
Yeah, the crown. When managing a canopy, arborists rely heavily on two specific techniques, crown raising and crown thinning. Now, crown raising is relatively straightforward in its purpose, right?
Very much so.
You're just elevating the lower edge of the canopy by selectively removing those bottommost branches. And if you manage a commercial property, you already know this is absolutely crucial just for compliance.
You have to clear sidewalks and driveways.
Exactly. You're meeting municipal codes for pedestrian clearance and ensuring vehicle sightlines aren't obstructed at intersections.
Because obstructed sightlines near parking lot exits or low-hanging branches interfering with walkways, those are major immediate liability flags. Crown raising physically removes those hazards, ensuring the property meets accessibility standards while keeping the space fundamentally safe for daily foot traffic.
Yeah, so the compliance aspect of crown raising makes perfect sense. But the second technique, crown thinning, that requires a bit more scrutiny.
It does.
The guides define crown thinning as the highly selective removal of inner branches, as well as dead or diseased wood, to increase light penetration and air movement through the center of the tree.
Right, getting air and light in there.
And I totally understand removing dead wood. But if you look at an overgrown, dense tree crown, it's solid. It's robust. If you start intentionally cutting out the live inner branches of that tree, aren't you removing the internal load-bearing structure?
Ah, I see what you mean.
Like if you hollow out the center of a building, the roof collapses. So aren't we structurally weakening the tree's core by hollowing it out?
It's a great question, but the structural architecture of a tree operates on entirely different principles than a static building.
Okay.
The inner branches you're removing during selective crown thinning, they are not primary load-bearing supports. They're actually secondary growth that the tree produces to capture stray sunlight. But over time, they add immense unnecessary density and weight to the overall structure. What's fascinating here is the physics of wind resistance.
Oh, wind resistance.
Exactly. By selectively removing those inner branches, trained arborists actually alter the aerodynamics of the tree.
Oh, wow. So you are changing how the tree interacts with the storm.
Precisely. Think about an unpruned, incredibly dense canopy. It acts almost like a giant ship's sail catching the wind.
A sail. Yeah, that makes sense.
It absorbs the full, brutal, blunt force trauma of a windstorm, and it transfers all of that kinetic energy straight down the trunk and right into the root plate. By thinning the canopy, you drastically alter the drag coefficient.
You're opening it up.
Yes, you transition the canopy from a solid wall into a permeable structure. The thin canopy allows high-velocity winds to pass safely through the foliage. You are drastically lowering the wind resistance, which significantly lowers that lever action pulling on the roots. And that prevents the entire tree from uprooting during a severe weather event.
Here's where it gets really interesting, though, because reducing wind resistance isn't just a generic, good to have piece of advice in these guides. The sources focus specifically on the environment of the San Gabriel Valley, where West Covina is located.
Very unique climate.
Right. They describe the local environmental challenges as a brutal, unrelenting stress test. The urban forest there goes through this seasonal weather whiplash that tests every single mechanical aspect of those trees.
The San Gabriel Valley provides an intense environmental crucible. You have a distinct, punishing seasonal cycle that pushes trees to their absolute physiological limits. It begins with the long, arid Southern California summers.
Right, just brutally dry.
These extended periods of intense heat cause severe drought stress. And when a tree is severely dehydrated, its natural biological defenses plummet. It can't produce the necessary volume of sap to defend itself, which makes it highly susceptible to fungal pathogens and aggressive pest infestations.
And the guides specifically highlight the threat of bark beetles during this drought phase.
Nasty little pests.
Yeah, and the mechanics of how they operate are just ruthless. I mean, they don't just eat the leaves. They specifically target drought-stressed trees because they can sense that drop in sap pressure.
Exactly. They know when the tree is vulnerable.
So they bore into the trunk and rapidly accelerate the tree's decline by destroying the vascular tissue, that cambium layer just under the bark. They essentially cut off the tree's internal plumbing.
Right. Starving it to death.
Exactly. So to combat that specific biological threat, the texts emphasize the absolute necessity of proper deep watering and soil conditioning during the hottest months.
Yes. By hydrating the root zone deeply, you allow the tree to maintain its vigor and keep its sap flow high. That hydrostatic pressure inside the tree, that sap flow, is literally what physically pushes the boring beetles back out when they try to breach the bark.
Wait, really? It just flushes them out?
It catches them out, yes.
Yeah.
It's a physical defense mechanism.
That's incredible. So you deep water the tree all summer to keep its internal pressure up and fight off the beetles? But then the seasonal cycle flips. We hit the winter reversal.
And everything changes.
The environment goes from bone dry to brief periods of intense, heavy winter precipitation. The rain saturates the soil, and suddenly that dirt loses its structural integrity. It can no longer anchor heavy root systems.
It turns into soup.
Yeah, so you get this lethal combination. You have a massive tree sitting in saturated, loose soil, and then the infamous Santa Ana winds sweep through the valley, creating immense aerodynamic pressure against the canopy. Like a wrestler on a slippery, wet mat, If the ground is saturated, they have absolutely no grip.
That is a perfect analogy, which brings us right back to the physics of the canopy. A top-heavy tree acting as a solid sail in saturated soil is incredibly vulnerable. The root plate simply doesn't have the friction to hold the lever upright against that kind of wind force.
But wait, let's look at the timeline here. If property managers are deep watering these trees all summer long just to fight off the bark beetles, aren't they just creating a dangerously saturated root zone right before the winter rains hit?
Ah, I see the concern.
By the time the storms roll in, hasn't the constant summer watering already turned the soil to mush, effectively doing the storm's job for it?
If we connect this to the bigger picture, you have to look at the rate of transpiration and how the tree actually processes that water. The deep watering done in the summer is strategic hydration, not flooding.
Mm-hmm.
That moisture doesn't just pool in the ground for months. It is actively absorbed by the root system, pulled up the trunk, and transpired out through the leaves into the hot summer air.
So the tree is drinking it up fast.
Very fast. By the time winter arrives, the summer water has been fully utilized and the soil has normalized. The real defense against those winter storms isn't trying to manipulate the soil moisture level right before the rain,
Mm,
because you have zero control over a winter deluge.
right.
The real defense is that late summer or early fall canopy thinning.
You prep the sail before the storm.
Exactly.
You alter the aerodynamics of the canopy so that when the ground inevitably turns to mush from the winter rain, the wind just passes right through.
You reduce the kinetic energy transferring down the trunk, so the roots, even in compromised saturated soil, aren't subjected to enough shear force to cause a catastrophic failure.
That makes total sense. Now, because that wind and rain are so punishing, you can't just apply a one-size-fits-all strategy across a property. The mechanical stress tests different species in completely different ways.
Absolutely.
The texts provide a fascinating breakdown of the local species and their distinct structural vulnerabilities. A towering eucalyptus is going to react to that Santa Ana wind entirely differently than a dense oak.
You truly cannot treat an urban forest as a monolith. If you manage a property, you have to understand the specific biology of your inventory. Take eucalyptus varieties, for example.
Right.
They have an extremely fast growth rate. And from a structural standpoint, fast vertical growth usually means lower wood density and a high center of gravity.
Like a tall, thin tower.
Yes. Furthermore, they develop relatively shallow root systems. So you essentially have a skyscraper built on a weak foundation. Because of that rapid growth and shallow anchor, they require professional inspection every 6 to 12 months, specifically to monitor for high wind failure.
The eucalyptus sounds like a beautiful but dangerous sports car, you know? Fast, flashy, but highly prone to crashing if you aren't careful.
That's a very fair assessment.
On the complete opposite end of the spectrum, the guides profile the California live oak. The texts note this species has a slow to moderate growth rate and famously dense, heavy wood. They recommend an inspection every 12 to 18 months.
Right.
But if you are a homeowner or an HOA board member looking at a massive, slow-growing oak with incredibly dense timber, you might naturally assume it is fundamentally safer and more stable than that fast-growing eucalyptus.
The common misconception.
Right. I mean, why does something that solid still require specialized annual structural inspections? Since it grows slowly, shouldn't it be safer?
This raises an important question about how we perceive structural integrity in nature. We tend to equate slow growth and heavy wood with invulnerability, but heavy wood brings its own unique set of liabilities. The risks associated with the California live oak are often silent, insidious threats.
Silent threats.
Yes. The sources identify two primary hazards for the oak: sudden branch drop and root disease.
Sudden branch drop, the guides mention that. It's a particularly terrifying phenomenon.
It is, because it defies our typical understanding of weather-related failures. It often happens on perfectly calm, windless summer days.
Wait, really? With no wind at all?
No wind. As the dense wood undergoes intense hydrostatic changes due to heat and internal moisture fluctuations, internal microcracks form. Without any external trigger, a massive, heavy limb simply snaps and falls.
Just out of nowhere. Wow.
Yes. Furthermore, oak root systems are highly susceptible to specific fungal diseases. These pathogens can silently rot the anchor of the tree entirely underground, digesting the roots, while the canopy up above still looks perfectly green and healthy.
Oh, that's scary.
You have no idea the foundation is gone until the entire massive structure tips over.
So the inspections aren't about checking how fast it grew. They're about checking for invisible internal decay and hydrostatic stress. The texts also detail native palm trees. They have moderate growth, but demand inspections every 6 months. That's largely because of heavy frond drop. I mean, a falling palm frond is a massive, heavy, spiked projectile dropping from 50 feet in the air.
It can do serious damage.
Then you have species like the ficus and the sycamore. They grow fast and require annual inspections, but their primary risk isn't in the air, it's underground. They have incredibly aggressive surface root expansion.
And that surface expansion is a direct response to the urban environment. In many commercial and residential spaces, the soil is heavily compacted and lacks oxygen.
So they can't breathe down there.
Right. So the roots of a ficus or sycamore will naturally stay right at the surface to hunt for gas exchange and moisture. When those roots encounter concrete sidewalks or driveways, they don't stop. They exert immense, unrelenting hydrostatic pressure, slowly lifting massive slabs of concrete and creating severe tripping hazards.
Just busting up the pavement. The texts also mention citrus and fruit trees. They require annual inspections and are highly susceptible to disease. The key management tool here is annual dormant pruning.
Yes, very important for fruit trees.
And the mechanics of dormant pruning are fascinating. You're intentionally pruning the tree during its inactive winter phase to redirect its stored energy. Instead of letting the tree waste energy growing excess foliage in the spring, the pruning forces the tree to push that energy into developing thicker, structurally sound branches. Branches capable of actually holding the immense weight of the fruit it's about to produce.
Exactly. Every single species on a property demands a highly tailored management strategy based on its unique biological architecture and the specific liabilities it presents to the surrounding environment.
So, what does this all mean when maintenance simply isn't enough? What happens when a tree crosses that invisible line from being a managed structural risk into becoming an active red alert emergency?
That's the critical threshold.
Yeah. The sources transition from preventive care into the subterranean threats and the signs of imminent catastrophic failure. And this is where anyone managing a property needs to pay absolute attention.
The indicators of imminent failure are highly specific physical changes in the structure of the wood and the surrounding soil. If you observe deep vertical cracks suddenly forming in the main trunk, or if the tree develops a severe lean that wasn't there a month ago, the structural integrity has already been compromised.
The guides also heavily emphasize looking out for peeling bark and the sudden appearance of large fungal brackets growing near the base of the trunk.
Yes, fungal brackets, which look like little rigid shells growing directly out of the wood near the soil line, are the fruiting bodies of a massive mycelial network operating inside the tree.
Wow.
Their presence means that a fungus is actively digesting the lignin and cellulose inside the trunk. The structural wood is literally rotting away from the inside out.
Oh, man.
You might also notice significant dieback in the upper canopy, where the very top branches are completely dead and bare, indicating the vascular system can no longer push water up against gravity. But perhaps the most immediate alarming sign is soil heaving at the base of the tree.
Soil heaving, that's when the ground on one side of the trunk literally starts lifting up and cracking open, right?
Correct. It means the root plate is acting as a lever against the earth, and it is actively losing its grip.
It's tearing out of the ground.
Yes, the subterranean anchor is failing, and the tree is in the slow process of kipping over. When you see soil heaving, emergency intervention is required immediately because a collapse is imminent.
An emergency intervention in densely populated residential or commercial areas is incredibly complex. Like, the texts detail this surgical precision dismantling process.
You can't just chop it down.
Right, you don't just cut it at the base and let it fall. It's like playing a massive high-stakes game of Jenga over someone's roof. Professional crews have to dismantle these massive structures, section by tiny section, using complex rope rigging systems, pulleys, and massive cranes.
The math involved is staggering.
They have to calculate the dynamic load, the immense shock force of a multi-ton branch free-falling and suddenly catching on a rigging rope, all to protect power lines, underground utilities, and the neighboring houses sitting just a few feet away.
It is a high-stakes physics equation happening in real time. Operators are working chainsaws at high elevations, calculating the exact trajectory, swing radius, and weight of falling timber, ensuring the kinetic energy is safely absorbed by the rigging rather than transferred into a residential roof.
But even after you safely dismantle the canopy and the trunk, the threat to the property isn't over. The subterranean threat is relentless. These aggressive root systems naturally seek out moisture and oxygen.
They don't just stop because the tree is gone.
Exactly. The texts explain how roots can infiltrate microscopic cracks in older plumbing lines. As they expand inside those pipes, they exert a massive hydrostatic pressure, shattering the plumbing. They can lift concrete driveways, and they can literally crack shallow residential foundations.
That hydrostatic pressure possesses incredible force. This is why arborists often install physical root barriers deep underground during the early stages of planting to physically redirect that biological growth away from hardscapes and structural foundations.
Which brings us to the stump that's left behind after removal. The sources emphasize industrial stump grinding, which utilizes heavy machinery to grind the dense wood well below the soil surface so you can immediately plant sod or pour new concrete.
A very necessary step.
But looking at this from a property manager's budget perspective, stump grinding is expensive and disruptive. Isn't it cheaper and honestly more ecologically natural to just cut the tree flush to the ground and let the stump rot away organically over time?
I hear that argument often, but leaving a massive stump to rot organically near a residential or commercial building is essentially installing an incubator for structural disaster.
Seriously? Because of pest infestations?
Primarily, yes. A rotting stump is a massive concentrated food source. It becomes a magnet for structural pests like subterranean termites, carpenter ants, and wood-boring beetles.
Oh, I see.
They are inherently drawn to that decaying organic matter. Once they establish a massive, thriving colony inside that stump, it is only a matter of time before they exhaust that food source and naturally migrate the short distance to your home's wooden structural framing.
So by leaving the stump, you are effectively providing a staging ground for a termite invasion right next to your foundation.
It is the ultimate staging ground,
Yeah.
and the secondary threat is geological.
Geological.
Yes. A mature tree has a massive subterranean root network. As that network slowly breaks down and decays over several years, the organic matter literally disappears into the soil. This creates massive, hidden voids underneath your lawn, your driveway, or your walking paths.
Wow, just empty spaces underground.
Exactly. Over time, these voids turn into dangerous sinkholes. Someone is walking across the lawn, the ground gives way, and you have a severe injury and a major liability claim.
Yikes.
Industrial stump grinding completely eradicates that central root crown, removing the habitat for pests, stopping the tree from aggressively sprouting new shoots, and allowing you to manage the soil properly to prevent those voids.
That is wild. To bring this all together, whether you are an HOA board member managing a sprawling complex, a commercial property developer, or just a homeowner enjoying some shade on a Sunday afternoon, the core realization here is profound. Trees are not passive background scenery.
Got it all.
They are dynamic, incredibly powerful living structures. We can't just casually admire them.
Right.
We have to actively respect the physics, the aerodynamics, and the subterranean biology at play.
Proactive arboriculture is a mandatory investment in safety and asset preservation. It requires a constant analytical recognition that the environment above ground and the biological network below ground are constantly interacting, constantly shifting, and constantly reacting to the stresses around them.
It fundamentally changes how you look at the urban environment around you. In fact, there's one final thought I want to leave you with, directly inspired by connecting two separate biological mechanics in these sources.
Oh, yeah.
We just learned that aggressive root systems naturally seek out moisture and can exert massive hydrostatic pressure capable of shattering concrete foundations.
Right.
We also read in the text that during construction projects, arborists strictly advise installing protective fencing around a tree's drip line to prevent heavy machinery from compacting the soil and suffocating those roots.
Right. The goal is to preserve the soil structure and oxygen levels directly under the canopy.
But think about the unintended consequences of that on a busy job site. If heavy construction machinery relentlessly compacts all the soil just outside that protective zone, it's going to force rainwater to pool and drain entirely differently across the property.
Oh, that's an interesting point.
Could that severe localized soil compaction inadvertently redirect those aggressive moisture-seeking root systems straight toward the path of least resistance, which might just be the freshly poured shallow foundation of the newly built house they were trying to protect in the first place?
A definite possibility.
It's something to ponder the next time you walk past a bustling construction site and see a beautifully preserved, majestic tree safely surrounded by heavy machinery. Is it really safe, or is it quietly, biologically becoming a multi-ton liability waiting to happen? Thanks for joining us on this deep dive.